Dear students, in continuation with the series of numericals, we have another numerical which is based on the electrostatics. Now see here, if we go through this numerical, it is based on the electric field. Now, electric field and the combination of vectors. Now if we go through this 2-point charges Q1 5 under root 5 microcoulomb and Q2 is minus 16 microcoulomb are placed on the x-axis. At x equal to 1 meter, this we can type origin. At x equal to 1 meter and x equal to 4 meter respectively. Means Q1 is placed here root 5 into 10 raised to the power minus 6. Q2 is minus 16 into 10 raised to the power minus 6 coulomb. Find the electric field in volt per meter at a point y is equal to 3 meter on the x-axis. Now at this point P, this is say O, say we can call it as a and we can call it as a B. So at this point we have to determine the electric field. Now this distance is 1 meter and this distance is 3 meter and this distance we have taken into consideration. Because of this there will be electric field and it is having a positive charge, so electric field means the force which is acting on it will be in this direction, that is given by E1. So E1 is the electric field which is because of the A, where Q1 is placed under root 5 into 10 raised to the power minus 6 coulomb charge. Another charge which is kept here at B, which is minus 16 into 10 raised to the power minus 6 coulomb, which is acting in this direction because this is a positive charge and this is a negative charge. So there the electric field will be acting in this direction. Now both the electric field, one is acting in this direction, another is acting in this direction. We have taken the angle as theta, so this electric field will make an angle theta with the horizontal. Similarly, this electric field E2 which is acting in this direction also making an angle alpha with the horizontal. Okay, so E1 that we can determine root 5 into 10 raised to the power minus 6 and R1 which we have got under root 3 square plus 1 whole square, that we have got this 10. 9 into 10 raised to the power 9 root 5 into 10 raised to the power minus 6. So ultimately if we will calculate, we will get the electric field 900 under root 5 volt per meter. Okay. Now here electric field because of the charge Q2. Electric field because of this A2 1 upon 4 pi epsilon naught Q2 upon R2 square. So here we have got this 9 into 10 raised to the power 16 into 9 into 16 into 10 raised to the power minus 6. This distance is 4 and this distance is 3. So we can calculate this distance. 4 square plus 3 square. This will give the 16 plus 9, that is 25. And 25 means 5 square. So finally we will calculate 144 into this 1000 divided by 25. So 5760 volt per meter. Similarly we have got E1 for 900 root 5 volt per meter. Now if you see the electric field, their component one is E1x which is in this direction, E2x in the opposite direction. Because of this E1y which is acting perpendicular to this y component and E2y is the vertically downward. So if you see the net electric field because of these two E1 plus E2, we will go through the x component and y component. E1 of x, it is of minus I because it is acting in this direction and it is, that's why we have taken minus. E1 y jk plus E2 x ik plus E2 y minus jk. Now if you substitute minus E1 cos theta ik plus E2 cos alpha ik, E1 sin theta jk minus E2 sin alpha jk. So ultimately if you will substitute the value of this E1 and E2, we have substituted here minus 900 root 5 upon 1 upon root 10 plus 5760 into 4 upon 5 ik. Thus 900 root 5 plus 3. Now 1 upon root 3 is root 10 cos theta. This angle theta. Now we know that base upon hypotenuse. Similarly for sin theta, perpendicular upon hypotenuse, that is 3 upon under root 10. For cos alpha, we have this alpha. So it is 3 and it is, we can determine this is your 4 and this is 3 and this is 5. So finally we will have cos alpha, that is 4 upon 5, and sin alpha perpendicular upon hypotenuse, this will give the 3 upon 5. So when we will substitute and we will calculate the value, we have got the electric field minus 900 upon root 2 plus this multiplied with 4 I cap plus 2700 root 2 minus 3456 jk. So if we calculate finally, we will have the final value 3971.60 I cap minus 146.81 jk volt per meter. So finally we can calculate the electric field and we have got this. So if a question like this is given to us, we can solve it in this manner, resolving the components of the electric field, how the electric field is acting, because here it is a positive charge, because we know electric field is the force experienced by a unit positive charge. So once when we are placing a unit positive charge here, this force is acting in this direction, means it is a force of repulsion, and the electric field will be always in the direction of the force. Similarly, a force which is acting in this direction, this is the attractive force, because positive charge here and a negative charge here. So there will be a electric field which will be acting in this direction, PB. So ultimately we can have the resultant effect and we can calculate it in terms of the x components and y components, and finally we will get the answer. So this way we can go through these such numericals.